It began with silence, a silence so deep, it swallowed the echoes of wings. 10,000 bats, no exit, no light, no way out, just darkness. And then stillness. What happens when nature's most elusive, most feared creatures are locked in together? With no sky to escape into, and no clue why. What do they become when stripped of their freedom, their instincts caged, their senses overwhelmed? This wasn't a science fiction film. This was Rwanda, 22 deep in the country's southern province. Carved into the old volcanic rock lay an abandoned mining shaft, nothing more than a scar on the hillside. To the untrained eye, it was just another forgotten tunnel, too unstable for industry, too remote for tourism. But hidden inside, clinging to the ceiling in writhing shadows, lived a massive colony of Egyptian fruit bats. For years, they went largely unnoticed. The villagers nearby knew to keep their distance. They'd heard the high-pitched screeches, at dusk seen the black blur of wings against the twilight, and whispered stories, not all of them rational. Bats, after all, have long lived at the edge of myth, carriers of disease, creatures of the night, familiars of the uncanny. But to scientists, these bats weren't demons. They were clues. For decades, researchers had been watching them, tracking them, sampling them, trying to understand why these mammals seem to live in harmony with some of the world's most dangerous viruses. Ebola, Nipah, coronaviruses, and the one that started it all, Marburg. It was one of the deadliest viruses ever discovered, a filovirus much like Ebola, causing severe hemorrhagic fever with a fatality rate as high as 90%. First identified in 1967 during simultaneous outbreaks in Germany and Yugoslavia, it came from monkeys imported from Uganda. But the true reservoir of the virus, the organism that could carry it without dying, turned out to be Egyptian fruit bats. They don't cough, they don't collapse, they don't bleed from their eyes, they just live with it, fly with it, and sometimes spread it. This is what made the bats in Rwanda so important. And in 2024, something changed. A 27-year-old man from Nyamagabe district fellow with symptoms that baffled doctors. Fever, fatigue, vomiting blood. He died within days. Lab results later confirmed it. Rwanda had just recorded its first ever Marburg virus case. The government acted fast. Borders were monitored. Public health teams were dispatched. But the scientists, they rushed to the tunnel because they had been here before. They had tagged these bats, collected their droppings, swabbed their mouths and wings. They'd found viral RNA, antibodies, traces of exposure. But until now, there had been no confirmed spillover, no proof that the virus had made the jump from bat to human. Now they had it, and it was terrifying. And so, in a decision that sparked ethical debates even among their own team, the researchers proposed something radical. They would seal the cave, not forever, just long enough to observe, to learn. They needed to know, how does the virus spread inside a wild colony? How do the bats behave under pressure? And most importantly, is there a tipping point? Could this natural balance between host and virus break down? To do this, they would create a closed viral ecosystem, something never before attempted on this scale. First, they returned to the mine entrance under cover of night. The bats were already inside, roosting, sleeping. It was the perfect time. With a combination of steel mesh gates, acoustic baffling panels, and breathable environmental netting, they sealed the opening. Air could pass through. Humans could watch through motion-triggered cameras and infrared lenses, but nothing, not a single bat, could leave or enter. This was now a prison, but not for punishment, for discovery. Over the next few days, the scientists carefully began the second phase, internal monitoring. Using ultra-lightweight GPS chips and miniaturized radio transmitters, they tagged several dozen bats across age groups and roosting zones. With ultrasonic microphones mounted across the cave walls, they listened to the bats' clicks and squeaks. their way of mapping their surroundings in pitch blackness. Because bats don't use eyes the way we do. They use sound. They see with their ears. Echolocation, first discovered in the 1940s by scientists Donald Griffin and Robert Galambos, is how bats navigate in total darkness. They emit high-frequency calls, sometimes as fast as 200 clicks per second. The sound waves bounce off obstacles, walls, other bats, even insects midair, and return to their ears with subtle changes in frequency and timing. Their brains then reconstruct the environment as a mental 3D map. In wide, open spaces, they use long-range, narrow-band calls to detect distant objects, but in tight, cluttered zones, like this sealed cave, they switch to short, broadband pulses. These give them finer detail at close range. In theory, the bats should adapt. They'd flown through tunnels before, but what the researchers didn't count on was what happens when adaptation fails. Within 48 hours, the cave began to feel different. The microphones picked up unusual patterns, longer silences, fewer clicks, flight movements slowed. Some bats simply clung to the ceiling and didn't move. And that's when the first signs of stress emerged. It began as an odd, high-pitched whimper, a distress call, recorded only a few times in previous studies. Then another, then another. Soon, the cave was flooded with erratic chirps, wing flaps, and collisions. Bats began flapping wildly in place, freezing midair, or falling entirely to the floor, stunned. Something was going wrong. Asterisk. Why bats matter so much. Asterisk. The Egyptian fruit bat became the star of the show, but not by choice. The tunnel, now rigged with mesh and tracking equipment, was sealed, nothing in, nothing out. Researchers watched from outside, controlling every variable. It was the perfect laboratory chance to study how a virus like Marburg survives, moves, and evolves in the very species that hosts it. But there was more than just the virus. These bats are special. They carry some of the world's most terrifying diseases: Marburg, Ebola, Nipah, coronaviruses, and yet they live without symptoms. How? That question could hold the key to pandemic prevention and even medical breakthroughs. Inside the cave, tiny GPS tags tracked their every flap. Microphones captured their clicks, chirps, and cries, because bats don't see in the dark. They hear it. Through echolocation, they map the world using sound, bouncing high-frequency calls off walls and prey to build a mental blueprint of their environment. The system worked. The researchers had their data streaming in, but what they didn't realize yet was that something in the colony was beginning to change. Bats under stress. At first, it was subtle. A few bats clinging to the same spot for hours. A reduction in calls. Then came the signs of stress: racing heart rates, sudden bursts of flight, then freezing in place. You see, bats, like humans, have stress hormones. When they panic, their HP axis kicks in, releasing cortisol or corticosterone depending on the species. In other words, they get anxious, just like us. And in this sealed cave, stress spread like static. One bat let out a distress call, then another. Soon the entire chamber fell into a strange, tense quiet. Studies have shown that when bats hear those distress calls, they freeze. They stop everything. Their hearts race. They brace for the unknown. Worse yet, bats remember. Trauma stays with them. That cave became more than just a tunnel. It became a psychological trap. But the stress wasn't the only thing spreading in the dark. Virus transmission confirmed. 4 years. Scientists theorized that Marburg could jump from bat to bat, but they'd never seen it happen in a wild colony until now. Inside the cave, grooming behaviors revealed everything. The virus passed through saliva, urine, feces, even shared fruit. One infected bat was enough. Over days, viral markers began showing up in others. Biting, rubbing, defecating, all simple acts, now made deadly. Fruit contaminated with bat spit could still host live virus particles 6 hours later. Cave walls, soaked in guano. turned into silent reservoirs of disease. This meant a hiker brushing against a wall or picking up a fallen fruit could walk away with something lethal. They had their proof. Direct transmission was real. Surface contamination was real. But before the team could even process the gravity of their discovery, something far worse crept into the colony. Collapse of social structure. Overcrowding does strange things to animals. And in the sealed cave, space was running out. The bats began flapping more aggressively. Squeals and scuffles replaced their usual soft clicks. This wasn't random noise, it was breakdown. Behavioral sink. The psychological collapse of social animals under pressure. When bats are packed together, their echolocation starts to fail. Too many calls bounce around. The echoes interfere, sonar systems jam. Imagine a room full of people screaming directions at the same time. You wouldn't know where to turn. Studies showed bats in confined tunnels lost 40% of their ability to navigate. Crashes increased. Flight paths overlapped. It was chaos, without a clear social hierarchy. Because most bat species don't operate like wolves or chimps, there was no leader to restore order. But then, as if things couldn't get worse, a new threat emerged. White nose syndrome, the silent killer. Somewhere in another cave, thousands of miles away, a cold-loving fungus had been quietly wiping out bat populations. Its name, Pseudogymnoscus destructans, the fungus behind white nose syndrome. It thrives on cold skin, especially the kind found on hibernating bats, and it kills not by infection but by exhaustion. The fungus wakes them up again and again during hibernation. Each time, they burn more fat, until there's none left. In some North American caves, this disease wiped out 90% of local bat colonies. If even one infected bat in Rwanda carried spores on its fur, the sealed cave could become a mass grave. And this cave was packed, skin to skin, wing to wing. If it spread, it would spread fast. And there would be nowhere to hide. The scientists realized their experiment was on a razor's edge. Unexpected adaptation. Then, something shifted. The aggression slowed, the squeals lessened, and gradually, a new order formed. Bats began spacing out again, claiming new roosts. Some moved to cooler walls, others grouped with familiar partners. Grooming resumed. Even mating returned. Their calls, once a chaotic chorus, became synchronized, tuned. Echolocation signals started separating, each bat adjusting its timing and frequency like musicians learning to harmonize in a crowded room. Even their flight created airflow patterns that reduced toxic gas buildup. They weren't just surviving, they were adapting, evolving. And after 21 days, it was time. The researchers opened a gate. But what happened next was not what anyone expected. The aftermath and long-term effects. When the bats were released, they didn't flee in terror. They flew with caution, as if recalibrating. Their foraging paths changed, their vocal patterns evolved. Even their social clusters were different. Studies on hand-raised bats show that after captivity, many survive and thrive, but some don't. The stress can suppress reproduction. Behavior can shift permanently. Some become isolated, others cling tighter to known partners. These bats had been through something unnatural, and it showed. For a few nights, they avoided certain areas. Their flight paths were jittery, but gradually they settled back into routine. The colony had been changed, but it had not been broken. From darkness to drones, how bats are inspiring. Here's where the story takes a turn. Because what the researchers learned about echolocation and swarm behavior didn't just help virologists, it helped roboticists. Bats don't crash into each other, not even in the dark, not even in massive groups. They adapt their calls, react in real time, and make split-second decisions in perfect sync. That's swarm intelligence. And that's exactly what scientists are now programming into drone AI. From the University of Constance to Virginia Tech, engineers are copying. That's how they speak less when flying close, how they tune their sonar to avoid signal jamming. It's becoming the blueprint for swarms of drones that can explore collapsed buildings, war zones, even space. But the final twist, it wasn't just about flight. Asterisk groupthink and the bat mind asterisk. As the bats adapted, something curious happened. They began acting more like people. Researchers noticed patterns that looked eerily familiar: agreement without conflict, conformity over independence. It resembled a psychological phenomenon known as groupthink. When confined to a space with no escape, animals like humans begin to prioritize peace over truth. They suppress disagreement. They fall in line, not because it's right, but because it's easier. Some bats led, others followed. They grouped in ways that mimicked cliques. Some refused to share, others began grooming only select partners. And still, somehow, the system worked out. It's as if, in that cave, we didn't just discover how viruses spread or how I can fly, we found something deeper, a mirror. Because when you trap intelligent creatures in the dark for long enough, you don't just study them. You discover what it means to be alive.